I've got a mass, I guess I'll use Cu because I know it's copper this time, is 110 grams. So that's this right here. They give me the heat capacity right here. So specific heat of copper is equal to 0.20 joules per gram times degrees C. They tell me it's heated to 82.4 degrees Celsius. So that's a temperature initial copper. And that's going to be 82.4 degrees C. So it's heated to this temperature. And then it's placed into a container of water at 22.3 degrees Celsius. So the temperature initial water is 22.3 degrees C. That's right there. The final temperature of the water and the copper is 24.9. So temperature final is 24.9 degrees C in both cases. We want to know what is the mass of the water. Mass of water equals question mark. Okay. Now again, I can see, because I've done these problems before, that I'm going to need the specific heat of water. Again, we'll come to that.
So we can write W or H2O, right?
Yep, if you want to do H2O, that's fine. Yep.
Is it 4.184?
4.184, okay. Yep. So again, this is a case of Q lost equals Q gained. Because I got two things that are being mixed together. And so lost, that's going to be my metal, or my copper. And this is going to be my H2O. So again, I can say Sm delta T, what's losing the heat, the copper, is equal to Sm delta T of what's gaining the heat, that's the water. Okay, I'll expand it out. Specific heat of copper times the mass of copper times the temperature. Okay, now I got to think. Copper is hot initially, colder later. So initial should go first, minus the final. So I get a positive. Good. Specific heat of water times the mass of water times temperature final water, because the final temperature is going to be higher than the temperature initial of water. Okay, this time I want to solve for mass of water. So on this side, I'm going to get rid of specific heat of water, temperature final minus temperature initial water. And then that'll go away, that'll go away. Do the same thing over here. Specific heat of water times temperature final minus temperature initial water. And what I get is mass of water is equal to specific heat of copper times the mass of copper times the temperature initial copper minus temperature final, all over specific heat of water times temperature final minus temperature initial water. Are you with me so far? Yep.
So how come the delta T was different or what made it change? You know what I'm saying? Like
why this is initial and final initial?
Well, why is final on the right side and then over on the other side of the equal sign? Why is it the first one?
Because the only way for these two things to be equal is if they're the same sign.
Oh, so you just do it to make sure that they get the same sign?
Make sure they come out positive, yeah. You can treat the delta T in this problem, just in this problem, as an absolute value.
Okay.
And the reason I don't do that is because, again, if we were just going to solve specific heat, it wouldn't be an absolute value, it would depend. All right, so now we can plug in our numbers. So mass of water equals specific heat of copper is 0.20 joules per gram times degrees C. The mass is 110 grams. Temperature initial copper was 82.4. 82.4 degrees C minus the final, which was 24.9. All divided by specific heat of water. That's one we probably should know. Joules per gram times degrees C. Temperature final, again, 24.9 degrees C minus the initial, 22.3. mass of water equals, so I'm just gonna do my subtractions first, get that out of the way. So I have 0.20 joules per gram times degree C times 110 grams times 82.4 minus 24.9, 57.5. You see, all divided by 4.184 joules per gram times degree C. And then that should be what, 2.6? Mass of water. So let's see, what's gonna happen here? Joules per gram times degrees Celsius, that's all gonna cancel. Degrees Celsius, that's all gonna cancel, it's gonna come out grams. So I notice still some guys still stopping, calculating this, writing it down, stopping, calculating, writing this down, and then doing it again. Not very precise way to do it. Just type in 0.2 times 110 times 57.5 divided by 4.184. Get that answer, divide that by 2.6. And the answer is 12. No, I'm kidding. I tried.
7.
I got what, 116?
116.3.
Grams, and that's H2O. Okay, so that gets it done a couple seconds early. Before we quit too, it just made me think of a couple other things here.